Welcome to maths. Let's see some critical questions for limits. These are mainly engineering entrance oriented. Okay. Yeah, let t be the greatest integer less than or equal to t. Okay, greatest integer function basically brackets t. If there is a value p which belongs to natural numbers such that limit extends to 0 plus x times gif of 1 by x plus gif of 2 by x up to gif of p by x minus x square times gif of 1 by x square plus gif of 2 square by x square up to gif of 9 square by x square is greater than or equal to 1. Then what is the value of p? Basically, we need to find out the value of p. Okay. So let's see. We know that this gif functions are very interesting and sometimes we get confused. Okay. So always first find out what is the gif of the given function. Okay. Then you go to the next step. Okay. Here, in the first case, I have gif of limit extends to 0 plus x times n by x. Correct? X times n by x. Let's see this. N by x where x is positive and very small value, small positive value. Then what will be the value of n by x? It will be infinity. Okay. In such case, or n into infinity. Okay. And then you are multiplying with very small value of x. Okay. So infinity and uh, x value which is small value you can put aside, then you will get n value, right? So in limit x tends to 0 plus x times gif of n by x is nothing but n. Similarly, in limit x tends to 0 plus x square times gif of n square by x square is n square. Okay, once you know this problem is very simple, correct? Okay. So if you see the given expression, the first part will become x times the gif of 1 by x plus 2 by x up to p by x will become 1 plus 2 plus 3 up to p. Okay, and p is the natural number which is given, so which means this is equal to p into p plus 1 by 2. Okay, and the second part, limit extends to 0 plus x square times gif of 1 by x square plus 2 square by x square up to 9 square by x square is nothing but 1 square plus 2 square plus 3 square up to 9 square, which is sum of first 9 squares of natural numbers. Okay, so which is nothing but n plus 1 into n plus 2 into 2n plus 1 by 6, which is 9 into 10 into 19 by 6, which is 285. Okay, now all we know is the subtraction. Okay, difference of these two is greater than or equal to 1, which is p into p plus 1 by 2 greater minus 285 is greater than or equal to 1. So I get an inequality, quadratic inequality, which is p square plus p minus 572 greater than or equal to 0. Okay, if I look at the values where it is satisfied, the minimum value of p, least value, right? That's what is asked at 24. Okay, if I look at the root, it comes approximately 24, not 24 actually. Okay, so 24 is the value where this inequality is satisfied. This minimum value of p. Okay, so if you get a doubt whether it is 23, 24, 25, just once you know the value, you check the value of the expression and see where it is greater than 0. Okay, so 24 is the answer for this one. Next. Okay, for f from 0 to pi uh, to r, okay, rational number defined as f of x equal to 8 by 7 to the power of tan of 8x by tan of 7x for all x between 0 and pi by 2. Okay, if the x is between 0 and pi by 2, f of x is defined as 8 by 7 to the power of tan 8x by tan 7x. And if x is equal to pi by 2, then f of x equal to a minus 8. Okay, if x is between pi by 2 and pi, then f of x equal to 1 plus gif of cot x to the power of b by a gif of absolute cot x to the power of b by a absolute tan x. Okay, where a comma b are real numbers, and then if f is continuous at x equal to pi by 2, then what is the value of x a square plus b square? Okay, the information given is f of x is continuous at x equal to pi by 2, and for all the limits which are mentioned as continuous, you have to check the LHL, RHL, and then equate it to f of x at x tends to a. Okay, so first let us find out LHL and RHL. Okay, okay, for LHL it is x tends to pi by 2 minus, okay, slightly less than pi by 2, which means I need to take the f of x definition as 8 by 7 to the power of tan 8x by 7x. Correct? Okay, so I'll take this value, substitute x equal to pi by 2 minus h and h tends to 0. So the expression will become LHL is nothing but limit h tends to 0 minus f of pi by 2 minus h, which is nothing but 8 by 7 tan of 8 times pi by 2 h divided by tan of 7 times pi by 2 minus h. Okay, so this is nothing but, if I see 8 times pi by 2 minus h, this is minus tan h. Okay, and this will become cot h. Okay, so that is nothing but minus tan square h, okay, on the power side. Okay, so the simple equation is limit h tends to 0, 8 by 7 minus tan square h. Okay, if I substitute h equal to 0, I'll get 8 by 7 to the power of 0, which is 1. Okay, so my LHL is 1. Let's check the RHL. RHL is limit x tends to pi by 2 plus, so I should take this value 1 plus absolute cot x to the power of b by a absolute tan x. Okay, then substitute x equal to pi by 2 plus h and h tends to 0. Okay, so which means as RHL is limit h tends to 0 plus 1 plus absolute cot of pi by 2 plus h to the power of b by a absolute tan of pi by 2 plus h. If I simplify, this is what I get in the function 1 plus absolute tan h to the power of b by a absolute cot h. Okay, now this is, if I substitute 0, this is 1, this is b by a to the power of infinity, so 1 to the power of infinity, this is in the form of 1 to the power of infinity. So what will apply? The limit is nothing but e to the power of, if this is f of x, e to the power of f of x minus 1 into g of x. Okay, so let's apply that. RHL is nothing but e to the power of tan h minus 1, right? So absolute tan h, that is tan h, b by a to the power of cot h. Okay, so tan h and cot h will go off, cancels each other, and I am left with e to the power of b by a. This is my RHL. Now we know that LHL equal to RHL equal to f of x, which is a minus a. So if I equate them, I get e to the power of b by a is equal to 1, which means b by a equal to 0 or b equal to 0. This is one value. And second value comes from this one, a minus 8 equal to 1, which is implies a equal to 9. So my a square plus b square is 81. That's the answer. Okay. Next. Let f is defined as function is defined as real to real, R to R, rational to rational, be continuous at function satisfying f of 0 equal to 1 and f of 2x minus f of x is equal to x for all x belongs to real numbers. Okay. So if limit n tends to infinity, f of x minus f of x by 2 to the power of n is equal to g of x, then what is the value of sigma of g r square? R is from 1 to 10. Okay, what is the value of this one? Okay. So one thing is understand this, f of x is defined and f of 0 is not equal to any 0 or negative number, means it's a positive function, correct? It's a positive function, that is very clear. Okay, so once you know this one, you can extend this one to get the f of x value. Okay, so let's see how to do this. So f of 2x minus f of x equal to x, which is given, and f of x, f of 0 is equal to 1, okay, not 0. So f of x minus f of x by 2 equal to x by 2, correct? Based on the same, if I substitute 2x equal to x, this is what I'll get, right? So f of x by 2 minus f of x by 4 equal to x by 4, and so on. So once I know this one, if I sum up all these things, okay, my what is my last term? F of x by 2 to the power of n minus 1 minus f of x by 2 to the power of n equal to x by 2 to the power of n. Okay, so if I sum up all these things, okay, starting from f of x minus f of x by 2, what we will get is this one. Okay, this full expression, which is nothing but x by 2 plus x by 4 plus x by 8 up to 2 to x by 2 to the power of n. Okay, so once I know this one, okay, and on the LHS side, all the terms gets cancelled. I am left with f of x minus f of, okay, this will be minus f of x minus f of x by 2 to the power of n. Okay, this is what I am left with. Now I just apply limit on this one, okay, which is nothing but limit of n tends to infinity x times, okay, if I take x common, x times 1 by 2 plus 1 by 4 plus 1 by 2 to the power of n. This is in geometric progression, so it is nothing but x times 1 by 2 divided by 1 minus 1 by 2, which is 1. So this is g of x is nothing but x. Okay, once I know this, this is very very simple question. It's a sigma of g of r square, right, which is nothing but x square. So 1 square plus 2 square plus 3 square up to 10 square, which is 10 into, sorry, 10 into 10 plus 1 into 2n plus 1 divided by 6, which is 385. That's the answer. Okay, next. If flower bracket x denote the fractional part of x, okay, this is called fractional part, means if it is 1.2, this will return me 0.2. If it is 1.001, it will return me 0.001. okay, f of x equal to cos inverse of 1 minus okay, I'll just call it x square, okay, fractional x square, sin inverse of 1 minus fractional x divided by fractional x minus fractional x cube, okay, where x is not equal to 0. If LHL and RHL are nothing but L and R, and f of x uh, for the f of x. Okay, then what is the value of 32 by pi square into L square plus R square? Okay, so first find out LHL and RHL values, then that's it. That's the thing. Okay, so for LHL, fractional x, if you take, this is nothing but x minus integer part of x, which is gif of x, correct? So as x tends to 0, fractional x is gets equal to x only. There is no integral part, right? So this is equal to x. So once you know this, my RHL, which is r, is equal to limit h tends to 0 f of h plus x, which is nothing but limit h tends to 0 f of h, correct? Because x is 0 anyway. Okay, so limit h tends to 0 plus cos inverse of 1 minus h square sin inverse of 1 by 1 minus h by h times h minus h cube. Okay, so I can rewrite this as limit h tends to 0 plus cos inverse of 1 minus h square by h, and limit h tends to 0 sin inverse of 1 minus h divided by 1 minus h square. Okay, so this one is simple. This is nothing but sin inverse of 1. Correct. If I substitute h equal to 0, this is what I'll get, sin inverse of 1, which is nothing but pi by 2. So the partial limitation is fine. So I need to find out cos inverse, limit of cos inverse of 1 minus h square by h. Correct. So let's see how to do this. Okay, so let theta equal to cos inverse of 1 minus h square. So cos theta equal to 1 minus h square, and h is nothing but square root of 1 minus cos theta. So as h tends to 0, my theta also tends to 0, because if h is 0, this is cos inverse of 1, which is 0. So theta also 0. So this part of the limit h tends to 0 cos inverse of 1 minus h square by h is equal to limit theta tends to 0 theta by square root of 1 minus cos theta. Now we always know limit theta tends to 0 sin theta by theta is 1. So convert this square root of 1 minus cos theta in terms of sin theta basically. Okay, so what I will get is, this is nothing but 2 sin square theta by 2. So I'll get square root of 2 sin theta by 2. So I will add theta by 2 into 2. So finally, if I apply limit, what I will get is this sin theta by 2, theta by 2. I'll get 1, and 2 by square root of 2, which is nothing but square root of 2. So my r is nothing but pi by 2 into root. Okay, don't forget this pi by 2 here, which we calculated. So my r is pi by square root of 2. Okay, now let's find out L. Okay, similar way, fractional x is x minus gif of x, we already see. So as x tends to 0 minus, okay, 0 minus, fractional x is nothing but 1. Why? If I put 0 minus, that means it is 0 0.1, 0 0.001, let's say. So this will become 0 minus, okay, my value is gif of x is nothing but minus 1. So 0 minus minus 1, which is 1, correct? So understand this carefully. So fractional x is equal to 1 as x tends to 0 minus. Okay, only for 0 minus, not for everything. Okay, so now my L is equal to limit x tends to 0 minus cos inverse of 1 minus fractional x square, and sin inverse of 1 minus fractional x divided by x into 1 minus fractional x into 1 minus fractional x square. Okay, so once I know this one, this is very simple. Okay, this part, sin inverse of 1 minus fractional x, okay, 1 minus 1 basically. This part is, we know that this part is 1, because limit is tending to x equal to 0. So this is 0 by 0 form, sin x by x form basically. Okay, so this is 1, and the second part is cos inverse of 0 divided by 1 plus 2 divided by 1 into 2 basically. Okay, so that is nothing but, okay, cos inverse of 0 is pi by 2 and into 2. Okay, this is pi by 4. My L is pi by 4. So now R and L, both values we got. So 32 times pi square into L square plus R square is nothing but 18. That is the answer. Okay, so hope you understood how to do problems with fractional x and integral x. Okay, be careful and continuous. Okay, next. Let a is greater than 0 be a root of equation 2x square plus x minus 2 equal to 0. If limit x tends to 1 by a 16 times, okay, all this expression equal to alpha plus beta square root of 17, then what is the value of alpha plus beta? Okay, observe carefully. There is a quadratic equation here and there is one here. Okay, both are different. Are they different actually? If I divide this with x square, this is what I get. Okay, so both are same. So if you remember the quadratic equation very well, if a is root of this one, 1 by a will be root of this one. Okay, so if a, b are roots of this equation, quadratic equation, 1 by a, 1 by b will be roots of this quadratic equation. Once you know this problem is very simple, but you have to do very careful calculations. Okay, that is important. Okay, this is my quadratic equation. I can write it as 2 times x minus a into x minus b. Let's say a and b are roots of this one. So I can find out what is my a and b from quadratic formula. Okay, this is my a and b. Just note it down. Only you substitute it in the end. Okay, so that you will not have any confusion. And this is my second quadratic equation, which is written here, where the roots are 1 by a and 1 by b. So it will become minus 2 into x minus 1 by a into x minus 1 by b. Okay. So once I know this problem is simple. Limit x tends to 1 by a 16 times 1 minus cos this quadratic equation divided by 1 minus ax square. I will rewrite this as 1 minus cos x, right? 1 minus cos theta. This is nothing but 2 sine square theta by 2. That's what I am writing here. 16 times 2 sine square theta by 2. So theta is nothing but this quadratic equation, and I am replacing with in this format. Okay. So minus 2 into x minus 1 by a into x minus 1 by b divided by 1 minus ax square. Okay. Now I know that sine square theta by theta in limits is 1. Okay. Limit theta tends to 0. Correct. Uh, Sine theta by theta is 1. So I have one x minus 1 by a and x minus 1 by b I should get here in the denominator. Okay, squares, because this is a sine square. Correct? How can I do this? 1 I have already. If I take a square common, this will become 1 minus a minus x whole square, which is nothing but x minus 1 by a only. Correct? Here it is a square, right? We are in the sine square. So I need to 2 x minus 1 by a into x minus 1 by a. So I will get 1 from here. And this is not there, so I will multiply here and divide. That's all I do. Okay, so I will add one factor of x minus 1 by b whole square in the denominator and multiply in the numerator. That's it. Okay, so that's what I'm trying to do here. 16 times 2 sine square x minus okay, this minus 2 and 2 gets cancelled, and since it is a sine square, the minus doesn't matter actually. Okay, so sine square x minus 1 by a into x minus 1 by a. So I have already a square I have taken common, so x minus 1 by a whole square, and I am adding this part x minus 1 by b whole square into x minus 1 by b whole square. Right? Simple. Do the calculation very carefully. Now my this part, okay, this bold, whatever is bold is 1 basically. So I am left with 32. 16 into 2 is 32. Okay, and x is 1 by a, right? X tends to 1 by a, so 1 by a minus 1 by b whole square divided by a square, right? So now I substitute the value of my a and b and carefully do the calculation. Okay, this is very, very important calculation. You will finally get 144 plus 16 times square root of 17, which is in the form of alpha plus beta square root of 17. So my alpha plus beta is nothing but 170. That's the answer. Okay. Yeah, thank you. These are the 5 critical problems where calculation is important and continuity of limits is important, and then there is a GIF function, there is a fractional function. So variety of problems I want to cover in this video actually. So hope you know how to solve these problems when you get GIF, continuity and fractional part. Okay, and don't worry about the complexity of the calculations. You have to do apply all your number theory uh, formulas. Okay, so hope you enjoy this one. Thank you. Keep doing maths.